Welcome back, lesson 93 today. We are going to put some algebra together. I'm so excited. So two-step equations and then inequalities, okay? Equations that had to do with inequalities. All right, so let me refresh your memory. We've done this kind of equation, right? 2x equals 5. And to solve this algebraically, we divide both sides by the coefficient, right? The number beside the letter. And in this case, we would get x is equal to 5 over 2, or 2.5. You can leave it improper as long as it's reduced. All right, and then over here, if we had x, take away 1.5 is 3, we would add 1.5 to both sides and get that x is 4.5, okay? So what we're going to do today is put both of these skills together, all right? So, wonderful, let's do that. I'm going to start with actually example 3, okay? Because this is just integers, and I think that this is a good starting point. All right, let's say that we want to solve for x here. Okay, I've got a plain number equals 3x plus a number. So what I want to do to solve for x is to isolate it, get it by itself, okay? I like having it on the left side of the equal, but it's okay if it's on the right, okay? I can get an answer 5 equals x. It's the same thing as x equals 5, isn't it? Yeah, so it doesn't really matter. All right, so let's go ahead and solve for this x. So I would want to get rid of this positive 6. I'd want the x term by itself. So if this is added, I need to subtract it, don't I? Okay? And if I subtract from one side, I must do the same thing on the other side to keep it balanced. All right? So let's think column-wise what I have. Okay, I'm adding two negatives. Negative 15 plus a negative 6, right? It's like adding the opposite. So right here I should have negative 21. And over here, this 6 minus 6 goes away. That's good. I want it to go away. I just want the plain old letter, right? The plain old term that has the variable. So now, guys, this is easy. 3x is negative 21. What do I do? Oh, yes, divide by 3, right? So x is negative 7. And if I plugged that in, I'd have a true statement. 3 times negative 7 is negative 21 plus 6. Sure enough, that's negative 15. Got it right. Okay, if you had trouble, go back through and watch that again, all right? Okay, so let's look at one that has decimals. We can do that. So let's proceed to example 1. We have 0.4x plus 1.2 equals 6. All right, so we want to be able to apply our algebra here. So the x term is right here. I want it isolated, so I want to get rid of this 1.2, don't I? So I'm going to take it away. It's the only way it's going to go away. If this is plus, I have to take it away. If this were minus, I would have to add it to make it go away, right? Okay, so I'm taking away on the left. Well, have to be fair, have to come over here and take that away also. Whatever you do to the left, have to do the right. Okay, so let's see what we have on the left. This cancels. I have plain old 0.4x equals, okay, now this is 6.0. Take away 1.2, 4.8, correct? Now, I have something in front of my x. How do I get rid of it? Divide it out. If I divide the left side, I have to divide the right side. So 0.4 over 0.4 is 1x. Good, that's what I want, positive 1x. Now, bottom into top, I need to make sure I move my decimals, right? I can't divide by decimals, so move it over. If I move it here, move it here. All right, so 4 into 48? Oh, you're right, it's 12. Very good. And again, if I plugged it in, I'd get a true statement. All right, let's do one with fractions. Let's see how we do with that. So let's take negative 2/3 x let's take away 1/2 and equals 1/3. Wow. Oh, I see that I did not write 2/3. We will fix that. All right, so negative 2/3 x, take away 1/2, equals 1/3. All right, I'm solving for x, so something is subtracted. I have to move it by adding it. You're right. Okay, correct, I should say. Okay, so this cancels. On the left side, I have negative 2/3 x. On the right side, I've got two fractions. Oh, what do I have to do with fractions? Oh, yes, common denominators. So, I'll take 1/3 and make it 2/6. I'll have 1/2 equal 3/6, and now I can add these like denominators. So the fractions 2/6 plus 3/6 is 5/6. All right, so hopefully you see how I've gotten to this point. Now, if I have a fraction in front of the letter, I'm going to multiply by the reciprocal, right? A number times its reciprocal would be 1. Okay, now I also want it to be positive, so I'm going to multiply by negative, because negative times negative would be positive. 3/2 times 2/3 would give me 6/6, which is 1. Yay, I got a positive 1 coefficient. That's what I want. Now, if I did that to the left, I must also do this to the right. Now, don't do any flipping over here. Right? This is the only thing that you flipped. Multiply that same thing on both sides. All right, so we have a positive times a negative, so the answer will be negative. And let's reduce. 3 into 6 is 2. So 5 times 1 would be 5. 2 times 2 would be 4. And there is our answer. And you may leave it in that form, okay? And proper is fine as long as it's reduced. Now we did example 3. Now let's take a look at example 4. This one has an inequality, and that's okay. We're going to treat it just like it said that it was equal. If this was equal, you guys would know what to do, wouldn't you? You would add 5 to both sides and then divide by 6. Well, just because it's an inequality sign, a greater than or equal, a less than or equal, a greater than, a less than, it's still going to work like an equation that has an equal sign. So we're going to add 5 to both sides. So we have 2x. These cancel. I'm going to keep that sign just the way it is, right? And now divide by 2, and I get x is greater than or equal to 3. So that means I could plug in 3 and get a true statement. I could plug in 4, 5, 6, 7, and on to infinity. But I would not be able to plug in anything less than 3. Okay? So as long as this is greater than, this is greater than, all good to go. All right, gang, let's try the practice. They do want you to graph this, so let's remember how to do that. We're going to have -3, we're going to have 0, we're going to have 3. In this case, we will fill in the circle because we're including it, and we shade greater than. Okay? And there you have it. All right, let's do the practice. A through H, a lot of practice, but you can do this. And come back when you're finished, and we'll check them. So for A, I went ahead and skipped some steps. I hope that's okay because I knew I would run out of space on the board. So for A, I moved the 15 over. I added it to the 185. So 8x is 200. I divided by 8 and got x is 25. For B, I subtracted 1.5 on both sides. So I have 0.2y is 2.2. Then I divided both sides by 0.2 and got y is 11. All right, for C, I went ahead and added 1/3 to the 1/2 that was on the right. I got common denominators, so 5/6. I multiplied by the reciprocal of the coefficient on both sides and reduced and got 10/9. For D, I subtracted 3.5 from the 14, so I got 10.5 or 10.5. I turned that to improper, which I also did with the 1.5. I hope you see that. Whenever you're dealing with mixed fractions, mixed numbers, you need to turn them to improper. All right, so that 1.5 n became 3/2 n, and then 14 take away 3.5 was 10 and 10.5 or 10.5, which I switched to 21/2. So then I multiplied by the reciprocal of the coefficient on both sides, and I got n is 7. All right, for E, I subtracted 36, so 12 minus 36 was negative 24. Divide both sides by negative 6 and get P is 4. Okay, for F, I added 26 to the left side, okay, and got 4W is 64. And then I divided both sides by 4, got 16. Okay, for G, I subtracted 5. I see here, I subtracted, so I need a negative, okay? So I need to switch this, don't I? Oh, so glad we were paying attention here. Let me fix this. All right, so in this case, we want our circle on -2. There we go. All right, and I hope you see all that. I subtracted 5, okay, and then divided by 2. And then for H, I added 5 and divided by 2. And there is my inequality graphed, right? Open circle on 3, because we're not including it, so it needs to be open, and shading less than. Remember, if you're reading these left to right, in other words, you're reading variable, sign, number, then whatever direction this inequality is, that's the direction you shade. Okay, now this one's going this way, so I shade that way. All right, notice what RenWeb tells you to do. Have a wonderful afternoon, and we shall return tomorrow.